Sorry. All right, guys. I cannot talk over you. I don't have the voice power to talk over you. So if you don't want to learn and you don't want to listen, just put your head down and talk to your friends later. But here we go. We're on 1.2b, more applications with average rate of change. So before we've been focusing a lot on tables, right? Looking at tables and analyzing tables for average rate of change. Now we're looking at more of the graph and then diving a little bit deeper into what the words are. You don't need a laptop for this. No. Then do it at home. You don't need it right now. And so we're going to talk a little bit more about just being able to use a little bit of math sense and a little bit of common sense together to analyze graphs. Okay. So first thing up, I think I accidentally left the answers on the board, didn't I? Let's see. I did. You see nothing. All right. So first up here, first up, let me know when I can talk. Okay. So if you read this to yourself, I'm going to just summarize it. Overall, Thomas kept chart of how snow was falling, right? So as the snow happened, he said, okay, starting at noon, what's happening, right? So if you look, this is an example of where reading a graph, it's important to know what your x-axis represent and what your y-axis represent. So for this problem, our x-axis, notice, is our hours since noon, right? So it's our hours since noon. So it makes sense that this would be noon, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, blah, 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 right? Everyone understands that? Okay, 0 represents 12 p.m. This is going to be 12 a.m., correct? All right, and then our snow up on the ground is in inches. So this is half an inch, a whole inch, 1.5, 2 inches, 2.5, 3, 3.5, 4, correct? All right, now as we analyze, it says, what was the height of the snow at 4 p.m.? And how do you know? Well, if I'm looking for the height of the snow at 4 p.m., that means I'm looking for at what on the x-axis? When x equals 4. So we're looking for when x equals 4, what do we get? So we go to x equals 4, and what do we get? 4 inches. And how do we know that? Because we know that 4 p.m. is 4 hours after noon, right? Does that make sense? Okay. Now, this is important to be able to do because when you're finding the average rate of change, you have to be identifying specific points on the graph, correct? So it says here, what is the average rate of change between 6 p.m. and midnight? When we talk about average rate of change, you're focused on your beginning and your end, right? So for this function, we need to find f of what 6 hours after noon, and then find what is 12 hours after noon. So what is f of 6? 4, right? We go to 6, go up, and we get 4. What is f of 12? 0.5. Okay, that is all step 1 was making sure you'd be able to do was, can you read the graph? Okay, do I have enough to find the average rate of change? I do. Average rate of change tells me that I'm looking for the change in my y over the change in my x. So I went from 0.5 minus 4 over 12 minus 6. Y2 minus y1 over x2 minus x1, correct? Can I calculate that? Yes. So I pull out my handy dandy calculator and I'm going to get an approximate value of what? So we get approximately negative 0.58. What are the units for this? The paper's right there in the basket. Inches per hour. Remember, it's the unit of your numerator over the unit of your denominator. Our numerator tells us our inches, right? So if we come over here, that's our inches. Our denominator tells us our hours. So this is in inches per hour. Correct? So is it working from a graph any different than working from a table? No, not at all. Okay. You guys try to make things bigger than what they are, but it's really not. Okay. All right. So let's dive a little deeper. It says, over what 2-hour intervals on the graph was the height of the snow increasing at the fastest rate? Justify your answer. Okay. So the first thing we're going to identify is our 2-hour intervals that we're going to look at. Okay. As you can see, I've already highlighted a couple here for you. So we can talk about from 0 to 2. That's an interval, right? We can talk about 1 to 3. That's another interval of increase. So we can analyze what's happening from 0 to 2. And we can analyze what's happening from 1 to 3. Is there technically another interval I can analyze?
Yeah.
Is this a 2-hour interval? So we're in 2 hours. What about 0.5 to 2.5? Could that technically also be an interval?
Oh my God.
Could it not? Yeah, it could. That's an interval where it's increasing. So technically there are 3 intervals that I can analyze. I could go from 0.5 to 2.5 and analyze what's happening from there to there, which grew the fastest, right? So if I'm looking at my intervals, these are the intervals that we have our intervals. So now we're going to find the average rate of change for each one. What is the average rate of change for this one? What is the average rate of change for this one? Okay. I'm going to pull out my calculator to try to speed it up a little bit for me. So here's my handy dandy calculator, Sylvie. Turning Sylvie on. I'm going to reset her because who knows what the last thing I did on her. So I reset second plus 712. Second plus 712. So the first interval I'm analyzing is from 0 to 2. So from 0 to 2, I need to know what is the y value at 2 minus the y value at 0. Does that make sense? So I go to 2 and my y value is at 3. It gets really tiny, tiny, tiny. Is at 3. Minus what is my y value at 0? 0. And we already know our interval, and this is over a 2-hour interval. Does that make sense? So we went from 3 to 0 in a 2-hour interval. Agreed? From 0 to 3 in a 2-hour interval. So that's my first rate of change. Do which parts? So this is our interval of increase. We have 3 intervals of 2-hour increase, correct? Yeah. So I looked at my intervals of increase from 0 to 2. I found the y value at 2. What was the y value at 2? 3. Found the y value at 0, 0, and subtracted and divided. For average rate of change. Okay, because it's from 2 to 0.
Are we getting there where 3 is?
Yeah. Okay, let's see. I'm not sure where we're lost at. It's the exact same thing we've been doing, guys. Finding the intervals, changing your y over your changing your x. We've been doing it for 2 weeks. I'm like, if we can't do average rate of change.
No, I can do that.
So my ordered pairs are 2, 3, and 0, 0. And then I hit enter and I get 1.5. We're going to do it again. So I'm going from 1 to 3, but it's y2 minus y1. So I'm going to start with my x2, right? So I go to 3. And the value at 3, I'm going to say is like 3.8. 3.8. And then the value at 1, I'm going to go to 1. The value is 1. Change in my y divided by the change in my x, which is 3 minus 1. I hit enter, and that's its average rate of change. I'm going to do the same thing for 0.5 and 2.5. I go to 2.5. it's roughly, it's a little bit past 3.5, so I'm gonna put it at 3.6. So I have 3.6 minus, I'm gonna go to 0.5. It's gonna be roughly, say, 0.8. 0.8 divided by, and I went from 2.5 minus 0.5. That's all we're doing. Average rate of change. Nothing different. It's just that it's from a graph instead of a table. Hit enter. So out of my 3 intervals, which one had the fastest rate? The first one, right? From 0 to 2. Do we see that? So my average rate of change took place from 0 to 2. Okay, so here we have this equals, this makes me really nervous about a quiz over the table. This was 1.5, this was 1.4, 1.4. So this is the fastest inches per hour. The winner. What didn't you understand? Okay, let's see. Maybe looking at it. If you're from 0 to 2, I'm asking you, what is f of 0? What is f of 2? F of 0 is 0. F of 2 is 3. I'm just gonna stop at 3. What is the average rate of change? Average rate of change is the change in my y's divided by the change in my x. So I have 3 minus 0 over 2 minus 0, which equals 1.5. That's it. That's all we did. This is literally what we typed in the calculator. Okay. Okay. For 5 minutes, we're gonna start our quiz. Here we go. At about what time did the snow stop falling?
3:30.
What are we like? So here we're increasing a little bit, and then we're leveling out. I would say from 4 to 6. When snow stops, does it instantly start melting? No. So it has to have stopped at some point and then started melting, right? So when did the snow stop? Remember I told you that common sense part we were gonna have to use a little bit today? This is an example of it. Okay. Okay. So common sense or logic tells me that the snow had to stop before 6 o'clock because that's when it started doing what? Melting. Do we get that? Okay. So when did the snow stop? Around 4 o'clock, right? Around 4 p.m. I'm not being funny. I'm being serious. And that's because from here, did it increase anymore? Around 4 p.m. because no more increase, like, right? No more increase. Does that make sense?
Yeah.
That's how we know it stopped because it wasn't increasing, not even at the slightest. Okay. All right. 5. 5 I'm gonna leave for you to do, put a little asterisk by. It's gonna be part of your little talk to your neighbor. Basically, for 5, you're gonna act like a news reporter and you're gonna explain what a weatherman and explain based on Thomas's map what took place. Okay, we don't have time to do it, so I'm gonna let you do it later. But you're gonna explain to your partner as a weatherman. Sounds like around noon today, guys, we had a weird thing happen. The snow just started falling. Okay, that's all you're doing there. Okay, now 6. What was the average rate of change of the height of the snow between 1 p.m. and 6 p.m.? I'm going to let you do this completely by yourself. What is the average rate of change from 1 p.m. to 6 p.m.? Go. A-Rock. Yes, rock it out. Go. All right.
Is 0 12 p.m. or 0 12
0 is 12 p.m. 12 a.m. is the last.
PM, but the last.
Exactly. All right, it's 15 minutes. Here we go. So 1 p.m. to 6 p.m. My beginning and my end. So I need to find f of 6 and f of 1. What was f of 6? 4, right? What is f of 1? 1. So I'm now going to find my average rate of change, which is my change in my y over my change in my x. So we have 4 minus 1 over 6 minus 1. And what do we get? 3 over 5, which means in terms of this problem, there is a snowfall of 0.6 inches per hour during that time. Does that make sense? Yep. Yes? All right, this is our stopping point. I'm going to pass out your quiz.